Hi everyone. So today we are going to discuss about dependency inversion principle. It is usually misunderstood with dependency injection as well, but these two are quite different topics and we will talk about dependency injection in some other video. As usual, we will go through the definition, then we will see a live example and code it in C++. So DIP states that high-level module should not depend on low-level module and both should depend on abstraction. And the other part is abstraction should not depend on details. Instead, details should depend on abstraction. So now let's take a look at this tree class. Here we are storing the information about different node connectivity. Node 1 is connected with 2, 3 and 4. So it's parent of 2, 3 and 4 and 2, 3 and 4 are siblings to each other. So let's try to implement this class in C++ now. So this will be a tree class. And it will store the information about different nodes. This will be connections and let's include header file as well. Utility header file is required for pair. This should work now. Now let's create a method here as well for adding the edges, or we can call it edge. So this will be void add. This will take two nodes int u and v, and here it basically means u is connected with v as well as v is connected with u. So it's a bi-directional edge. This is low level design. Why it's low level design? Because here we are exactly implementing the details, how exactly we are storing these edges, how we are adding these edges. Now on the front end or on the high level, we have a tree printer class, and this tree printer class is not aware of these details. What it does, it basically takes a tree and as an object and try to print the edges or print the neighbors. So it is not aware of these details, and let's try to code it. Tree printer class will be here. Let's call it tree traversal. So it will, so in tree traversal class we will have a method. Let's call it print friends. It will take a tree object and a node. So if you give one as a node, so it will print all of the friends. So in this particular case, let's call 2, 3 and 4 friends of node 1. So it is not going to change anything. Now DIP principle states that high level design should not depend on low level design. Instead, they should depend on abstraction. But in this particular case, we will see our flow will be, we will see the design, initial design, then we will see the flow in that particular design, what's the issue, and then we will try to fix it with DIP. As DIP states that it should not depend on low level design. So, but we are doing quite opposite to that. We will be directly dependent on these details. So let's just access them here. And now we can print that if our first node, let's do it this way. So now if u is equal to node, which we are looking for, then we can say that node is connected with v, and we need another header file here. Now we can create an main method, and here we will create tree object, and let's add few edges. 1 and 2 are connected. Then let me just duplicate it. 1 and 3 are connected, and 1 and 4 are connected. So this is our tree which we have created here, and now let's try to print the friends of node 1, and let me make it static as well so that I can just directly access it here. In this particular tree we want to print friends of node 1. Now let's run it. And we can see the result. 1 is connected with 2, 3 and 4. Issue here is we are directly dependent on tree edges, and if in future somebody change the details or somebody change the design of tree class, then our high level design or front end will break. Let me just make it private here, and you can see it. Now it's broken. The code will not run, even it will not compile. You can see it, right? So this is the design flow. The design flow is, if we are directly dependent on low level designs, if high level is directly dependent on low level design, then the moment somebody changes the low level design, high level design will broke or the front end will broke. So we need to create an abstraction here such that it doesn't matter we change high level design or low level design, both will be unaffected with that. So for that, let's create an abstraction here, and we will call it interface. So this will be tree iterator, and let me just create here class tree iterator. Now this particular class, as I mentioned, is an interface, so it will have a pure virtual method, and it will return a list of edges. So it will return a list of edges, actually not edges, list of nodes 2, 3 and 4. This is going to be written by this particular method, and let's call it get friends, and it will take a node. So why it will take a node? It will take the node for which we want to get the friends. So in this particular case we were asking for friends of 1, so we will pass 1. Now this particular class is being inherited by tree class, so let's call it public tree iterator, and if that's the case, then we need to override this method as well, otherwise we can't create object of tree. This will, as this is going to be returning this list, so we need to create a vector here. Let's call it result, and let's return it. Now we will iterate all over the nodes or all over the edges, so this logic will be similar. And in this particular case we don't need this. Here we will just push the result, push the node into result. So let's now we can delete this one, or let's just keep it as it is. Here we can do an iterator, Okay, let me just delete it. Now here we are not going to get a tree class anymore. We will get a tree iterator. And then we will run an for loop, and we will ask tree iterator. Oh, sorry. We will ask tree iterator object to get friends for this node, right? And now we can print that information that node is connected with and run it. You can see the result. It's quite similar to the previous result, but the difference here is now we have introduced an abstraction or an interface, and our high level design is no longer dependent on tree object. Instead, it's dependent on tree iterator. You can see it here. And we do not need to change anything in main method thanks to inheritance, because we are passing a tree object here and we are accepting a tree iterator here. So it's all inheritance, and we do not have to change anything here. So this was first part, that high level design should not depend on low level design. Instead, it should depend on abstraction. So the second part was that abstraction should not depend on details. Instead, details should depend on abstraction. So that's the case here as well. Our tree iterator class is being inherited by tree, and here we are not dependent on the details. Here we are not dependent on the details. It's an interface, and we are forcing tree class to implement this particular interface, pure virtual method, so that other classes could access it. Now the benefit in this particular case is, even if we change the details, so let me just make it public again, and you can see our tree traversal class is unaffected. And if I make it public private again, then also it's unaffected. Even if I change the container here, so let's just say that in future I do not want to go with vector, I want to use set or map or queue or whatever container in future we want to use, we can do that. And our tree traversal class will be unaffected by that, because this interface is going to give us a guarantee that at the end we will get a vector list, and this vector list we are using here. So this was DIP principle, and see you in the next session. Thanks for watching this video.